9.2, as you can see, is on absolute value equations. So we're going to start with some opening preliminary examples, and I think it'll just help motivate the process. So if I said to you, we're in class, and said, think about numbers whose absolute value would equal 3. If I gave you a couple seconds to think about it, I really have no doubt that within a couple of minutes, probably less than that, probably the first answer I get might be 3, and then a little while later someone says, oh yeah, but also -3, because the absolute value of both -3 and the absolute value of 3 are both equal to 3. So we end up with those two solutions. Then if we went on and I said, let's think about numbers whose absolute value would equal -3, sometimes students might say, well, put a negative on the outside. I might have to remind them, well, no, we can't do that. We can only think about what could I put in where the variable is. And once I kind of restrict that type of thinking, it's like, well, then I guess there's nothing we can put in here, because every time I take an absolute value, remember by definition, absolute value is distance from 0. That's why we, quote, take the positive. So every time we evaluate absolute value, we get a either positive or potentially 0 result. We never get a negative. So there can't be a solution to absolute value if it's equal to a negative. And then kind of the last situation, the one I just mentioned verbally there, if we had absolute value of x equal to 0, there'd only be one way that could happen, and that would be if x equals 0. So if I think about these three situations, first of all, I want you to think about how, in all three cases, the absolute value is already isolated on one side. We have absolute value of something equal to, and then, the right-hand side. But the absolute value is isolated on one side. That will be our first step. We must isolate for the absolute value first. It's in caps. I will highlight it. That is crucial. This isn't one of those steps where it's like, oh, it's nice if you do this first. I think it makes it easier. Nope, this is the imperative. You must isolate and get your absolute value on one side first. So your goal is kind of what I have written there, absolute value of some expression. So where we're headed is what's on the inside will be more than just a variable. It might be, an actual little algebraic expression. But we want to get that absolute value isolated on one side of the equation and then equal to kind of getting our constant on the other side. That's our goal there first. Okay. Now, once we have that in place, we want to kind of observe what I call the special case. I'm going to use that language when we get into inequalities as well. So we had two special cases up above. So let's kind of fill those in. I didn't leave us a whole lot of room. But if we had the absolute value of something, let's say z, equal to a negative number, that is when we get our no solution case. So there it is right here. So if the absolute value is equal to a negative number, it's no solution. If we have the special case of the absolute value of something equal to 0, that's kind of a little different case as well. That's only going to happen if the inside goes to 0. So we would set z, whatever that inside is, equal to 0, and then we would solve. So those two occur maybe a little less frequently. The most common thing is then we're going to have a situation like in number 1, we're going to have the absolute value equal to a positive number, and then we're going to know we can set that inside equal to both the number and the opposite of that number, so the negative of that number. And again here, I'll say, and then we solve each of these, so and solve. All right, so it really goes back to those opening examples. Let's take a look at a couple of examples for ourselves. So absolute value of 5x minus 3 over 2. That entire thing is in absolute value. Minus 5 equals -1. Now, the first thing I want to caution you about, and anytime I say caution, it's because students have made these mistakes, right? Okay. this absolute value of, 5x minus 3 over 2, okay, that is not equal to, this kind of thing that gets a student no credit real quick. You don't just make every term on the inside positive. If it was that easy, I'd say do that. Okay, now think about why that's true in general. Let's say I have just plain numbers, absolute value of just, let's say 5 minus 3. Okay, that is equal to order of operations, absolute value of 2, which is 2. That is not equal to just 5 plus 3. You can't just make each term on the inside positive. So this is an important caution when you see absolute value. First of all, you have an x there. That x itself could either be positive or negative, number one. Number two, to evaluate absolute value, you have to have it simplified down to one number in order to be able to actually take the absolute value. So we have the double whammy of we don't have it simplified down to just one number, and we have this x in here, which itself could be positive or negative. Okay, so don't think that, oh, I'm just going to take it all and make it positive. All right, instead, we follow the steps. And the steps say the first thing that we do is we isolate for the absolute value, and we do that, in this case, by adding 5 to both sides. So we want to start by getting the absolute value all by itself on one side. So we now have absolute value of 5x minus 3 over 2 is equal to 4. All right, now we have the usual case. We have the absolute value equal to 4. So what is this really saying? I mean, not that you need to write this out, but if I gave you as an opening problem, if I had said, what number, when I take its absolute value, would give me 4, you would tell me, oh, well, that inside could either equal negative 4 or that inside could equal 4. That's what we're applying here. It's just that the entire inside, that whole z here, is itself the 5x minus 3. So this is when we drop the absolute value bars, is when we go to the appropriate setup. So we're recognizing that in order for the absolute value to equal positive 4, that inside is either equal to negative 4 or that inside is equal to 4. And so that's what we're doing, when we go to this setup down here and we're writing out these two inequalities. All right, with absolute value bars now gone, now we just have a little equation here to solve. So first we need to get rid of that denominator. So on both sides, really, of both equations, we're going to just multiply both sides by 2. And so now on the left here, we're going to have in our first equation, 5x minus 3 equals negative 8. On our second equation, 5x minus 3 is equal to 8. And then we're just going to continue to solve here. We just have a couple steps left in both of these equations. So we're next adding 3 to both sides. So we have 5x equals negative 5 in the first equation. But start to notice, this is where I'm not just getting plus and minus the same thing. I really need both equations here. It's not going to just be plus and minus the same answer when I'm done. All right, finishing it out, then, of course, both equations have to be divided through by 5. And then look at our answers. The first one here is negative 1. The second one is not just positive 1. Again, if it was that easy, you could just solve one and tack on the plus or minus, I'd tell you it was. But obviously here it's not. We get these two different solutions, negative 1 and 11/5. And again, you sub in the negative 1, the inside will simplify to negative 4. You sub in 11/5, the inside will simplify to 4. In both cases, the absolute value of those quantities would be 4. If you were checking it, 4 minus 5 gives you negative 1 if we're looking back at the very original. Okay, so this is like your primary example. This is what probably most of your problems will look like. Isolate for the absolute value. If it's equal to a positive number, it's the usual quotes. I'm doing air quotes right now. setup where you set the inside equal to both the negative and the positive. Let's do one more here. So suppose we have absolute value of 3x minus 2 plus 6 equals 2. Again, I say it because I see it. So the caution, all right? So the caution here is this is not just equal to, oh, I'm just going to make it all positive. Nope. You have the x, which itself could be positive or negative, and you have like more than one term, so it just doesn't work that way. All right, so how does it work? Well, exactly what we did up above. We start, first step has to be. Notice the other thing you can't do here. So that's caution number 1. Here's another caution. Caution number 2. Sometimes we learn more from our mistakes than we do doing something right. You don't just say, oh, I'm going to take this and set 1 equal to 2, and then I'm going to take the other one here and set it equal to negative 2. Okay, you're not isolated yet. Okay, so don't do this. So that is not okay. You haven't isolated for the absolute value yet. So the first thing we have to do is to subtract that 6. So when we do, we have absolute value of 3x minus 2 is equal to negative 4. And then we have to pause and see if we have a special case. Don't just say, oh, inside equals 4, inside equals negative 4. Not true here, because what do I really have? I have the structure of, if I said to you, absolute value of z equals negative 4, kind of thinking about those simpler opening problems, that can maybe help you to see, oh yeah, absolute value, no matter how complicated the inside, absolute value can't ever equal a negative. So this equation has no solution. So you kind of have to hit the hooks for a second after you isolate for your absolute value and see if you have a special case. If the absolute value is equal to a negative, it's a no solution. All right, let's do just one more. I think I said that was the only one, but I want to do one more. All right, one last one here, number 3. So on this one, suppose we have 2 times absolute value, 3 minus x, and then end the absolute value, minus 7 equals negative 7. All right, all the cautions still apply, but I'm not going to write them out. Let's start with the knowing now, hopefully what we need to do, which is start by isolating the absolute value. So I want to get the absolute value by itself, so I'm going to start by adding 7 to both sides. And so now I'm going to have 2 times absolute value of 3 minus x is equal to 0. Again, I want to isolate for that absolute value. I'm not done yet with that. It's multiplied by 2, so let's divide by that 2 that's in front of that absolute value. So I have absolute value of 3 minus x is equal to 0. So this is kind of, again, one of those special cases a little bit. This one's a little easier, I think. Absolute value equal to a negative, sometimes it's easy just to jump in and forget that it was a no solution. Here, if you're looking for where is the absolute value equal to 0, oh, well, that's just when the inside's 0. So we just set that inside equal to 0. So 3 minus x equals 0. And then lastly here, solving for x, just adding the x to both sides. So our answer on this one is x equals 3. Again, you can always sub these back in. If you sub in 3, the first term goes to 0, and you can see you get negative 7 equals negative 7. All right, when we come back in the next video, we'll look at just kind of a little extension of our absolute value, kind of the basic one. We'll kind of throw in absolute values on both sides. We'll look at that next time.